Good morning, Professor. The title of our group's research is to examine the differences in mathematics grades between male and female students in face-to-face and online courses. As you say, here are our group members. Actually, we have always been very interested in the topic whether boys are better than girls in mathematics. So we collected this data today to research this topic. Next, please. As you can see, we also showed these contents on our poster, but in order to show them to you more simply, we are using this slide to do this presentation. Next, please. This is our introduction about the source of data. Next, please. And this is our research objective and question. It's about the difference between boys and girls math scores. The most important thing is our hypothesis. There is a significant difference in math performance between male and female students. It's your turn, Guo Xingyun.
In this study, the non-hypothesis is that the two population means are equal, and the alternative hypothesis is that the two population means are not equal. Then table 1 shows that participants are 50 students, including 29 male students and 21 female students. Next, 58% minus 42% equal to 16%. 16% is less than 30%, so equivariance are assumed. Over to Su Wenjie.
Thank you, Guo Xingyun. This result was analyzed by SPSS 23. Since the number of male students exceed that of female students didn't exceed 30%, we should look at the value of equivariance assumed. We can see T is 0.582, degree of freedom is 48, and P is 0.563, more than 0.05, so that we can say accept a null hypothesis and reject a negative hypothesis. Overall, we can conclude that there is no significant difference in math performance between male and female students. My part is over. Next is Li Hongrui. Hi, Li Hongrui.
Okay, thank you, Su. As education majors, we became interested in questions such as whether online classes would affect student performance. Therefore, we connected data from the first year class 17 of Shaoguan Experiment Middle School. We used the math scores in January 2020 and June 2020 for our research. Next, please. Our second research objective was to examine the differences in mathematical grades between face-to-face and online courses. The research question was, do online and face-to-face courses affect math performance? We proposed two hypotheses. There is no significant difference in math performance between online and face-to-face courses. Alternative hypothesis, there is a significant difference in math performance between online and face-to-face courses. Next, my group member Yu Hanni will introduce.
Thank you, Rui. Good morning, doctor. I'm going to discuss our research into the paired samples t-tests. As we now see in the slide, the first table shows that the descriptive statistics used to compare the post-test math scores of males and females is show the value is 57.70, and the pre-test math score is 86.54. Next. The second table is about paired samples correlations, and it provides correlations. The value R is 0.98 between the two paired tests. It's obviously we can notice that R is 0.45, which is a moderate positive correlations and seem to provide good support for test reliability. These correlations indicate that students who score high on the post-test were very likely to score high on the pre-test, while students who score low were very likely to score poorly on the pre-test. More specifically, it indicates that the math test is systematically measuring primarily the same thing both times is taken. Thank you for listening. Turn to my group member, Luna.
Okay, thank you, Honey. Good morning, Dr. Nomula. I'm going to explain the third table. As you can see, the third table shows that the post-test score of math elicited a decrease of 28.84, with confidence interval percentage of 95%, from minus 35.884 to minus 21.796 among students compared to the pre-test math score. Next slide, please. And take a look at this table. It also shows that the post-test score of math elicited a statistically significant decrease among students with t-values equals to 8.228 and p-value less than 0.001. Next slide, please. And considering the above three tables together, we can make a conclusion that there was a statistically significant difference between means, and therefore we can reject the null hypothesis and accept the alternative hypothesis. And how about the effective side? Firstly, from the formula, it can be calculated that the d-value is equal to 1.16, and then compared to the value in the table above, we can conclude that there is a large effect according to Cohen's guidelines. Next slide, please. Okay, this brings me to my conclusion. That is, there is a significant impact on students' math performance between online and face-to-face classes. Thank you for your listening, and I hope you are enjoying and have a nice day.